Okay, the last of the videos for Lab 5. We're still on Lab 5, yes? So Lab 6. So in this case, we've got two more evaluations to do. Let me reduce this here. We've done this one, the Pythonic approach here, where we've evaluated these two expressions on the same line as evaluating these two expressions. And what I'm going to do in this case, I'm actually going to grab this entire statement. All right, and now this is a block of code for us. So a block of code, if you remember, is basically separated above by a blank line and below by a blank line. What I want to do is I want to take this exact approach down here and I'm just going to paste it in right here. So I've got the two approaches, the Pythonic approach, which is the modern way to do things, and you should prefer that. But you also need to know the traditional approach, and it very well may be that your first job, or maybe let's say a long-term job for you, will be to take old Python code and update it to the modern approach. What happens then is you're going to see old code in a way that's written, which often actually will be indicated by the errors that are thrown. So in this case, I want to break this statement up from this statement up. And what we're going to do is we're going to use this keyword called AND in between them. Now really what happens here is that and if I simply break these out in here, you really end up with the traditional approach here. You say if the min is less than user value, and also user value is less than or equal to the max, then it evaluates properly. But notice the warning on the screen, right? So Python is not, it's like, look, you really should do this, and it calls it a problem. It's not even a warning, but the idea of problems for us here in code is that it's going to be difficult to maintain. Others will approach your code with caution in some ways, or let's say with distrust, and we really want to be able to do it better. Now I'm going to let both of these two pieces of code run. In fact, the only thing I did here was add this and in between them, and let's see when this runs if we get the same approach on here. I'm going to do a -2 as my first value, and you can see that both of these two ways evaluated this as -2 is less than 0, let's say, or 0 is greater than -2. If again I give it a 111 in here, or just an 11, you can see that 11 falls between the range of 0 and 256. So both of these two blocks of code evaluated this the same way as well. And if I run this one more time, a 999 on here, you see that 256 is less than 999. So I want you to understand in here, it's not so much having you retype this code again, but the idea is that I want you to understand in some ways that we have let's say, a style of modern Pythonic code which replaces a lot of this old school format. And yes, this is going to be a warning, and it's going to live right here on my screen saying, hey, did you really mean to do this? Did you really mean to code it this way? But we need to understand what the, let's say, old school comparison values are, because when we reach this, or statements, we're required to use those old school values. Now what I'm going to do is I'm going to add another if statement in here. So I'm going to say if, for example, and what I want is I'd like to do an or value here. Now in the old way up here earlier on, we're asking if this value is less than this value, and also we're asking if this value is less than this value. Sorry, if this value is less than this value, which means this value is greater than that one. And we're also asking if this value is less than this value, or in other words, if this value is greater than this one. In some ways, what we're looking for in this or statement, we're saying if user value is less than the min, then you don't need to evaluate anything else, because I can stop right there. But what we're really doing is we're taking these two statements and we're flipping them. So I'm going to take user value here and I'm going to put it over on this side. And I'm going to take the min from over here and I'm going to put it over here. And so what I say is this: if it turns out that user value is less than the min, you can just stop evaluating, because this is definitely not a valid value, right? Because user value can't be less than the min. The whole point of all this was to make sure that user value fell between the min and the max. So if it turns out that user value is less than the min, then simply stop evaluating. However, that doesn't solve all of the situations. The user value might also be 299 over here. So here I'm going to add an OR. Whoops, an OR here. And it's suggesting it knows what it wants. But I'm going to also take these two statements right here, and I'm going to bring them down here as well. And I'm going to flip these. I'm going to take user value from this side, and I'm going to put it over here, and I'm going to take the max from over here, and I'm going to drop it in here. So notice what I'm doing here. I took this value and flipped it over here. So user value came to the other side of this statement right here, and also the min came over from this side over here. So I flipped these two values to be on the other sides of these. Same way over here, I took the max value and flipped it over here, and I took user value and I flipped it over here. Let me just read my statement. We call this a desk check to see if this makes sense to me. If user value is less than 0, then stop evaluating. However, if user value is not less than 0, then continue to evaluate and see if this side it is. If the max is less than and not less than or equal to here, if simply it's less than user value, this is the other OR. So by switching these two statements, I really want to find out, I don't need to worry about equal to in here. Because if the max, which is 256, is simply less than user value, but it actually has to be less than or equal to user value, doesn't it? So I'm going to go ahead and add that back in. So if the max is 256 and that's equal to 256 and that's true, you're right, it has to be just like this. Then this statement should also be true, right there, okay? In this case, what I'm saying is this. So the min is, I may actually have to rewrite this all together. So let's go ahead and rewrite it, because let's make sure that we've got what's going on here. So in this case, we would say user value in here. We'll type it the same way that we have it. User value is less than the min. Kind of wish it wouldn't do that. Is less than the min, okay? This part is true, and we're just trying to make our print statement evaluate to be exactly the same as what happened here, okay? But that's not the only thing that could have happened. It also could have been that user value was greater than the max, okay? Or in here, and we're going to add this one back in here, user value is, and let me make it be on a separate line here so you can see this, is greater than the max, okay? And in here, the max. I need to make sure I close that properly with all of these in here. So in this case, my OR statement, which is a traditional form, which has an expression on the left-hand side of OR, and also has an expression on the right-hand side of the OR, I want to check both values. So in this case, if user value is less than the min, then I say user value is less than the min, or user value is greater than the max. And just greater than the max, right? So the max is less than user value. It doesn't worry about equal to in here. So if it's greater than the max, which is all I care about, it can be equal to the max. That's fine. I don't need to worry about that. But this should actually come out here as well. I have a single blank line missing out here. Let's run this to see if this is actually giving us what we want. Okay, so in this case, if I give it a -2, I find that both of the two old evaluation statements actually print. So it's true that -2 is greater than 0, and true that -2 is greater than 0. Here I say -2 is less than 0, or -2 is greater than the max. I do have the or in here. I'm going to pump this up just a little bit. Or -2 is greater than the max. And so actually what I can do in here is I can say, I don't need to reprint the user value in here, or is greater than the max. We run this one more time. What I'm trying to do is I'm going to do a -99. I'm trying to make my expression here make sense. So -99 is, in fact, I'm going to add another word, is either less than the min or is greater than the max. And I'll see if I can run this one more time, and I'll give it a -11 in here. What I'm after here is this made a lot of sense. The min 0 is greater than -11. Here, -11 is either less than 0 or greater than the max. Let's try this with a 999 value. Here, the max is less than 256, and here 999 is either less than 0, which isn't true, or is greater than the max, 256, and that is true. Let's run this one more time and give it 256. Okay? In this case, the min 0 is less than 256, and, the min 0 is less than 256 and less than or equal to, the min is less, that's right. But if you notice, it didn't evaluate this as being equal to 256. Why in this or statement? Because we didn't evaluate that yet. Let's go ahead and add that in. So elif in here, and simply saying if the user value, in this case, user value is, in fact, we'll say exactly equal to the max here, then we can print and say a formatted print statement in here, and let's do this the right way. We can say user value is, it likes to autocomplete, is equal to the max. And we'll say that the max is the max. So in this case, we've evaluated if it's either less than or greater than, but here we can actually get in there and handle this, okay? And so I can go ahead and run this. Now when I give it a 256, we can say all three expressions are evaluating. Both of these which are inside of here, and also this which is equal to this. But that's not really what we wanted in here, is it? Let's go back if we can and look at the lab code and see where that was in here. But we can say in this case, if you notice, this will evaluate if it's outside of the ranges in here. We also could just do a single or statement inside of here, which basically checks that if everything is inside of this. So we could do an elif statement in here, elif in here, and we could say, let's switch these. If user value, if the min is in here, actually, we can really streamline this. We could just say else, right here, else. If it's not outside of the bounds, then it's within the bounds, is really what it is. So what I'm going to do is I'm going to go back up here and grab this statement right here, because this print statement evaluated if it was properly inside of the bounds. So there's no reason why we wouldn't just use this as its own else statement. Here, I'm simply going to drop it in there. If it's not outside of the bounds, then it's inside of the bounds. And in this case, I don't need to have several different else statements in here. I can simply go ahead and then run this. If I give it a -2, I can see that the min is greater than 2, the min is greater than -2, and -2 is either less than or greater than this. I can run this again, and give it, let's say, the 111, which is a range that's inside of there, and you can see all three evaluation statements are running the same. And if I run it one more time with the 999 or lucky sevens, you can see that 777 is either less than 0 or greater than 256. I'm just going to show you here this. If you notice, I have 1, 2, 3, 4, 5, 6 lines of code getting to do the exact same thing in here. These 6 lines of code does what this one right here, 1, 2, 3, 4, 5, 6, 7, 8, 9 lines of code does up here. So this 9 lines of code right here in some ways can be simplified into this 6 lines of code if I go backwards and use this traditional syntax, which is these 2 expressions on the other side of OR. Now, I'm not suggesting to you that you want to always make your code be compact, but sometimes it's helpful for you. If we can use more compact code and get the exact same feature out of what longer 9 lines of code did before, and even 9 lines of modern code does for us here, then we really are in the right spot here. So this lab has you exploring 2 different ways to do an AND statement, both with a modern Pythonic approach and also with a traditional approach, which you'll often see is required in other languages. And with this traditional approach, instead of using AND, but in substituting OR in here, you can see that we can get a more streamlined version of code that does the same thing that it takes longer lines of code to do up there before. I hope that these videos are helpful for you in understanding these concepts and also in finishing your work.